Hello everyone. Today we'll be solving Leetcode contest 387. So let's get right into it. And the first problem, we are given a distinct integer nums array of length n, and there are two arrays that we have to create, and we put a particular element from the nums array into the first array if the last element of the first array is greater than the last element of the second array, and so on. And if it is greater, we put it on the first array. If it is not greater, we put it on the second array. And after forming our two arrays, we have to just concatenate both the arrays. So let's just go into the code. So we first push the first element from the nums into the our array one. Then we push, if the size is more than one, then we push the second element to the array two. And then from third element till the last element in the nums array. If the back element, the last element from the array 1 is greater than the last element from the array 2, we just push it in the number in the first array, else we push it in the second array. And then we just in put one by one all the elements from both the arrays into our answer array. So that is the solution for the first one. Let's go into the second problem. In the second problem, we is it second problem? Yeah, it is. This is the second problem. Okay. So in this problem, we are given a grid of uh, m by n size, and we are given an integer k. Now we have to find the number of submatrices whose sum is less than or equal to k, and the matrix should start from the top left corner. Okay, so I'll just go to my Microsoft whiteboard. So let's say this is our this is our matrix. So one of the different submatrices can be this or this or this or this, something like that, or this, or even completely. But it should always start from the top left. So what we do is, what I did was that if you can, it is a very uh, intuitive thing to see that, let's say I am right now, let's just work on this bigger array, okay? So let's just work on, yeah, let's work over here. So let's say I have the value till here, the sum of this value and then this value. Okay. Then what will be the value of, let's say, this submatrix? It will be whatever the value I have till over here in the upper layer plus whatever value I got starting from this point till over here. So let's say what will be the value over here. Whatever the value I have over here, and then plus starting from this point, whatever sum I calculate from here. So that is basically it. So whenever we are parsing through this array, we just calculate the sum and put it over here, and then add the value. We just add the sum to the value which is just above it. That's it. So let's just go directly to the code. Okay. So we make a grid 2, which will be storing all the values. And then we just initialize every single value with the value 0, and we keep our counter right, and we just return the count in the last. So we loop for every row, and then we loop for every column, but in every row we have to calculate the sum, right? We have to calculate this value, this we'll be calculating the sum. So every single time we initialize the array with 0, the sum with 0, and then we'll be calculating this as we go from left to right. So we add the value to the sum, and then if the current row is 0, then obviously it won't be having any row above it, right? So directly the value in ij in the first row would be directly sum, whatever sum we have calculated till now. Else, no, sorry, and then if whatever value we have right now for this particular uh, I and jth coordinate, if it is less than equal to k, we count plus plus because this is what we have to return, right? If this particular value at any point is less than equal to k, we just add our counter, right? Add one to our counter. Else, if it is not the first row, if not the first row, then we in our grid we add sum and whatever value we had, just one step above it, right? So whatever value, if we are, let's say, calculating the value for this one, then we calculate starting from here till here, whatever the sum we get, and then whatever value we had over here, because this will be storing the value from over here till here, right? So we just take that and then just we just take the sum of this row and then we just add these two. So that's it. And if the value over here is less than equal to k, we just increment our counter. So that was the solution for second problem. Let's get on the third. In this one, okay, we are given a zero indexed n by n grid where n is odd, okay, and grid RC is 0, 1, or 2. So either the value will be 0, 1, or 2, okay. We say that a cell belongs to the letter Y if it belongs to one of the following, okay. So we are given a diagonal starting from top left till the center of the grid. Then we are given a diagonal starting from top right cell to the center of the grid, okay, and then a vertical line from the center till the bottom of the grid, okay. The letter Y written is written if and only if, and all these conditions should be true. At the start, I thought it is an or condition, but actually it is an and condition. Every single three of them should be true at the same time. All values at cells belonging to the Y are equal. So whatever value the Y is made up of should be equal. So 1, 1, 1, 2, 2, 2, 0, 0, 0, every single value should be same. All values at cells not belonging to Y should be equal. So whatever the value we have in these cells which does not belong to Y should be equal, either 0, 0, 0, 1, 1, 1, 2, 2, 2. And the values in the cell Y and the cell which do not belong to Y should not be equal. So if it is made up of 1, the rest of the cells can be made up of 0 or 2, and so on. And we have to tell how many digits do we replace with some other digit so that we can have our Y in the given matrix. So as we can see over here, if we just put 1 over here and then just make everything 0, it becomes a Y. Okay, so what I did was I I'm giving an overview and then okay, wait, I'll just go to an example. Okay, so for this one, first of all, we need to traverse the matrix so that we have to first traverse this way and then this way and then this way, right? So as you can see, if we want to traverse this way, and let's say n is equal to 5, because this is a 5 by 5 matrix, then we have to go from 0 till 2, and the indexes would be 0 comma 0, 1 comma 1, 2 comma 2, right? 0 comma 0, 1 comma 1, 2 comma 2. So this is traversed. To traverse this, you can just see that the sum of row and column is always 4, which is basically n minus 1. So 0 plus 4, 1 plus 3, and 2 plus 2. It will always be 4 to traverse from upper right to the bottom left. So you can do that, and that is how you can traverse this way. And then to just go bottom, you just do start your iterator from center plus 1, so basically 3, and you go till n minus 1. So it will cover these two. So that is how you traverse the traverse Y. So that was the first part, and then you have to calculate the number of zeros, ones, and twos in the Y that exist. So let's just go to the code. I'll show you through the code. Wait, okay, wait, I'll explain to you a little bit and then we'll go to the code. So we can keep a map of the zeros and the ones and the twos, the count of zeros, ones, and twos in the Y present. Okay, so we can do that to keep a count, and then we can have another map of the count of zeros, ones, and twos in the whole matrix. We can maintain that as well. And if we just subtract these two quantity, we can find the number of zeros, ones, and twos in the rest of the matrix, in the matrix which does not belong to Y, right? So now our strategy is, you can see that to find the overall answer, we need to see the total answer is basically changes made in Y plus changes made in rest of the array, which does not belong to Y, right? So if we just sum these two, we have the answer. So what I did was I just brute forced it. So basically, for one time I kept it as zero and this as one, because so I'm assuming that every single element in Y would be zero. The rest of the matrix will be filled with one. Then it will be one. This rest of the matrix will be filled with two. It will be two, and the rest will be filled with, let's say, zero. Then two, one, and so on. So one, zero, and okay, 0 and 2. Yeah, so these are the six possibilities, and I'll just iterate through every one of them and just see. So let's say, for example, we are filling Y with 1 and rest of the matrix with 2. Then how many changes will we require? Okay, that we have to calculate, right? So let's put the code. I did it little lengthier way. I think there are ways to solve it uh, in a more optimized way. But let's see. So at the start, we keep our int y total. This y total is basically how many elements are there which forms a y. Okay, so that this is very basically that. And then total count is total count of zeros, ones, and twos in the whole of matrix. And I just initiate. So what I do is I go to every single element and I just increment the counter for that particular value. And answer is basically our overall answer. And then this function basically gives the count of every zero, ones, and twos of the element present in the y. So it basically does this but for y. And how do we do that? So let's go to the function. It returns a map, takes the grid and takes n, and we have defined center as n by 2, obviously. Then what we do is we start from 0 and we go till center. And as I told you, if you want to go from top left till the center, you just do I comma I, 0 comma 0, 1 comma 1, 2 comma 2. So that we do. And we increment our y total as well, because we want to calculate total number of elements in y as well, right? So that is there. And then I just calculate sum as n minus 1. So sum is basically 4 plus 0, 3 plus 1, 2 plus 2. So basically the sum of these indexes will always be n minus 1. So that is what sum is. And how do I traverse this? So I take I and then I just subtract I with sum. So sum minus I comma sum minus I. And I just increment whatever value I had in the grid over there. So and to go from center till the bottom, I just go start from center plus 1 and go till n minus 1, and obviously the x-axis will remain constant at center, and I return by count. Okay, so we have our total count, the map of 0, ones, and twos in the whole of array, and we have y count, the map of zeros, ones, and twos in y. Total number of elements is obviously n into n. Now y0, y1, and y2 are elements are basically zeros present in y. So how many zeros are present in y? Y total, sorry, y0 is number of elements that needs to be converted so that the y is completely made of zeros. So that would be y total minus count of zeros. How many elements do you need to change to make y completely made of 1? Total number of elements in y minus number of elements in y which are 1. So this is basically that. And then over here we have zero rest is basically how many elements do we need to change in rest so that every element in the rest is zero. total count of 0 minus y count of 0, right? So that is what we do over here, and we do it for every single one of them. Wait a second, I'm sorry, I'm sorry. Zero rest is total. Zero rest is basically zeros in the rest of the array. Sorry, it is not how many elements do we need to change so that the rest of the array has all elements zero. No, it is not that. It is zero rest is how many zeros are in the rest of the array. How many zeros are in rest of one? How many zeros are in rest of two? Because we are subtracting total count of two with y count of two. So we got that and we put it in an array. So we put this value in this vector, and then we are calculating how many zeros do we need to convert, how many elements do we need to convert to zero so that our whole rest of the array becomes zero. So that is rest of the total minus zero rest. And what is zero rest? It is number of elements which are zero in the rest of the array. So we do that, and then we just push these three values in our vector as well. Okay. Now why are we doing this? So this over here is basically us doing a brute force. We are going through all the combinations 0, 1, 1, 2, 0, 2, all of them. If I is equal to j, because we can't have both of these elements in y and in elements in the rest of the array as the same. So that is why if I is equal to j, we just continue. We don't do anything else. If y array I, so now this is why I pushed it in vector, because so that I didn't have to write a lot. If y array I plus rest array I, number of elements that we need to change in y, so that I can get 0 in y, and j, it can be 1 or 2. In rest of the array, the sum of these two should be less than answer. If it, no, no, sorry, if it is less than answer, then I update my answer as the minimum of the sum and the answer. Okay. And then I just, at the last, return the answer. So we are just finding the minimum, this value, changes made in y plus changes made in rest. And we just return the answer. Okay, that explanation took way longer than I expected. Anyways, let's go into problem 4. Really low number of people have solved it, and I know why so few people have solved it. And let's see. So we are given an array of n size, and we have a function grade count. Okay. If in the grade count, if the inputs are an array and a value, okay, and return the number of elements in ARR that are strictly greater than val. Okay, so this function returns number of elements which are strictly greater than val. Okay. So we need to distribute elements in nums into two arrays. So we have a num array, and we have to distribute the elements in this num array into two smaller arrays. In the first operation, we appended the first element to the first array, and second element we append second element to the second array. Okay, and then for the further elements, if this function value is greater than this function value, so basically function value greater count function value for the first array is greater than the function count value for the second array, we append the nums array's ith element to the first one. If it is less than to the second one, if it is equal, then whichever array has a lesser number of elements. And still, if it is if both of the arrays still have same amount of elements, then we just append it to the first array. Okay, and then we just concatenate both the arrays and just return the result. Okay, so let's see the code. So the main thing is over here that let's say, let's take an example. Let's take this example, right? So this is 1, 2, 3, 4, 5. Now This is our array 1, array 2. Now the first will go over here, the second will go over here. Okay. Now for the third one, we see how many elements in this array is less than, I think, right? Strictly greater. Okay. How many elements are greater than 3 in this one? 1. How many elements are greater than 3 in this one? 1. So both, it can go in both of them, right? So then we check which array has a larger size. Both of them have equal size. Okay, if that is also not there, then we just push it in the first array. So it will go here. What about 1? How many elements in this array which has more elements than 1? Both of them. How many elements in this? 1. So it will go to the first one. Okay. What about this? This array has two elements greater than 2. This array has only one element greater than 2, so it will go over here. So it will be basically, and then when we concatenate, it will be 5, 3, 1, 2, and 14. Let's see if that is the answer. 5, 3, 1, 2, 14. Okay. So now the main trick is, the main problem is that how do we find and as you can see, the time complexity required is n log n, or n square root n in the worst case, because then n is 10 power 5. So what we need to do is we need to find in log of n the number of elements which are greater in any particular array, array 1 and array 2, greater than nums of I. We have to find number of elements greater than nums of I in array 1 and array 2 in log of n, right? How do we do that? So there can be other ways as well to do this, but one of the ways which is using a external library called PBDS, and over there we can find a data structure called ordered set. So this ordered set in PBDS, what we can do is we can just directly know what index does an element in this array lies at. So we can't do that with the set from the standard template library or even multiset, right? But if we use ordered set, and this is only found in PBDS external library, we can do this. We can find the index of this particular element, right? If we have the index of that element, then we can just subtract, and then there is a function in this ordered set which gives you the number of elements which are smaller, strictly smaller than whatever element you uh, searched for, right? So we need to find how many elements are greater than this, right? So what I did was I find the index of this. I know the total number of elements in the array, which is basically array1 dot size. I subtract from the array1 dot size whatever value I get from here. Let's say I'm calling it index, and then I just subtract. So let's say I'm searching for 2. There might be already 2's over here present, right? So then I just subtract number of count of 2 that I've already encountered, and I keep a map to store this value. I keep a map to store the values, to store the number of nums I have encountered, and this basically tells me how many elements are smaller than nums I. I do it for this one as well and for this one as well, and then I can compare both of these values. So let's go to the code. So by using this, you can just include the PBDS library, and as you can see, this over here we have formed a ordered set, and we can use the function. I'll just show you the function name as well. Order of key. So whatever key we put over here, it sends the index of this key, right? So in starting, we have created two maps, and in this map will be storing the count of nums I we have encountered in array 1 and array 2. Okay. This vector is basically the array 1 and array 2 vector. Okay. And we are creating obviously two ordered set S1 and S2 for both the arrays. We first push in the first array the first element, we push the second element in the second array if uh, size is greater than 1, and we are also incrementing the value in M1 as well. We are incrementing the counter as well. We are incrementing the counter for the array 2 as well, and we are pushing it in the set as well, and we are pushing in it the element in the array as well. So we have to do three tasks in the same time, right? And then for the rest of the elements, starting from 2, we find out the index of a particular num_psi. Then we calculate this first and sec value. This what is this? This is basically the value of this function, right? So what we do is we take the size, we subtract the index, basically number of elements which are lower than this particular value num_psi in array 1, and then we subtract the number of times we have encountered or pushed a particular element num_psi in array 1, right? We do this and we do it for both of them, and then it is pretty simple after that. If first is greater than sec, we push it in the first array, we add it to the ordered set 1, we add it to the map of 1. If it is smaller, we do it for the second array. If both are equal, we then we check the size. Obviously, if the size of 1 is smaller than 2, we do it for we add it to the first one, else we add it to the second one. If both of the sizes are equal, then we just add it to the first one, and then we just concatenate both the arrays and just return the answer. Thank you so much. I was rushing through the code a little bit, rushing through everything a little bit because I have to catch a bus. I'm in college right now. I'm a Masters of Science Computer Science student at Illinois Tech, and if you want to follow me, you can follow me on LinkedIn. The link will be in the description, and I hope my work helped you guys a lot. Thank you so much. Take care.